Hello again, everybody. We're going to look at some more coordinate plane ideas for our day 2 notes. Starting off with a couple word problems. It says that Mary is saving her money for a new bike. Look at her chart and graph the results. So let's go ahead and look at the chart for amount of money saved. So after a month, it seems like she saved $5. And then after 2 months, we saved $5. Okay, so I guess no money saved from month 1 to month 2. Then 3 months, $7. 4 months, $8. And then after 5 months, saved $10. Okay, so I'm not saving a whole bunch, but what we can do is we can take this information and we can put it on the coordinate plane. Now there's one big thing, major thing that we need to know for this class and for all of the math classes that you will see is that whenever we have time, so months is a unit of time, just like seconds is a unit of time, days are a unit of time, years is a unit of time. Anytime we have a unit of time, this is going to be our x-axis variable. So we will put the months on our x-axis. I actually want to label the x-axis months. So this represents 1 month, 2 months, 3 months, 4 months, 4.5 months is in there. Half a month is about 15 days or so. So we have our months axis, and then on the side it says the amount of money saved. That's going to be our y-axis. So we're going to say our amount of money saved. So it's important whenever we're working on the coordinate plane is if we ever have using the coordinate plane to represent real life data, we want to make sure we label our axes. This is going to help us with any confusion that we have about the meaning of the coordinate plane. You always should first look at what your axes represents, always, before you start jumping into any problem. All right, so let's go ahead and we can plot this information, this data on the coordinate plane as coordinate points. So the first one, we're going to plot 1, 5, 1 for x and 5 for y. Let's go ahead and plot that. So after 1 month, she saved $5. After 2 months, she saved $5. So let's go ahead and plot 2, 5. After 3 months, she saved $7. So there's 3, 7. And after 4 months, she saved $8. And then after 5 months, she saved $10. So we're going to plot the point 5, 10. All right, so we can see that the information that's in the table, the data that Marie is collecting, can be represented on the coordinate plane. This is one of our many ways that we can represent data. We looked at histograms before. We looked at two-way tables, and we looked at box and whiskers plots, but we're primarily going to look at graph representation of information or data. So there we go. So the big thing, again, to recognize here is that when you have a table of values are coordinate points. This is called a table of values. A table of values can be written as coordinate points and thought of as coordinates on the coordinate plane. So this is just a visual picture of what this data information is representing. So we can see clearly that her amount of saving is going up. Now let's look at another example. It says Tom's shoe store is keeping track of how many pairs of shoes they sell over a 5-month period. Graph their results. What I really want to get you guys to be able to do is create a coordinate plane on your own that helps describe information. So you can see here that we have a table, but our coordinate plane is missing a lot of things. First off, it's missing the scale. The scale means the numbers it's going up by. So right now we have a scale of 1 because it's going up by 1 unit every time, 1 month. And the y-axis scale is also going up by 1. So we have a missing scale. We need to think of something that's appropriate for the information that we have in the table. So let's go ahead and start by labeling our axes. We have months and pairs sold, pairs of shoes sold. So remember, months is time. This is going to be our x-axis. So our x-axis is going to represent months. Now, when we pick a scale for months, we should be looking at the table values to see what is our highest number we have to get up to, what's our lowest number we have to go down to. And I can see we only have 1, 2, 3, 4, 5. So a scale of 1 is a good choice. Maybe you can have a scale of a half even would be good. Either way is fine. There's a couple different scales you'd want to pick. And there's definitely a couple different scales you don't want to pick. You don't want to go up by 5s. That'd be way too much. If you went up by 5s, the first one would be 5, and then you're already done with the information because you're only going up to 5. So going up by 1s is good. Let's see. We want pairs of shoes sold. That's going to be our y-axis. So let's go ahead and label that. This is pairs of shoes. And we'll write the appropriate scale for the amount of pairs of shoes. So look at what your lowest pair of shoe is. Your lowest pair of shoe is 16. So that's the lowest. 16 is your lowest, and 30 is your highest. So we have to get all the way up to 30. This is why 1 is a bad idea for a scale. Don't write this, but I want to show you. If we did 1, we would only be able to get up to, we have only 10 here. We'd only be able to get up to 10. So we definitely don't want to choose a scale of 1. If we want to get up to 30 and we have 10 of them, I hope you're thinking to yourself what the best scale is. Best scale is going to be 3. Because if I have 10 of them, 10 little notches here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I have 10 of those and I use 3 as a scale, then 10 times 3 is 30. I'll get to my highest one. So let's go ahead and go up by 3s. So 3, 6, 9, 12, 15, 18, 21. 24, 27, and 30. So we got up to our highest one. So 3 is a good scale here. Now we can go ahead and start plotting the coordinate points. So let's start off with 1, 16. 1 is going to be x, 16 is going to be y. So 1 and then up to 16. Well, we don't have 16 on our y-axis, but it's somewhere in between 15 and 18. Definitely closer to 15. So I'm going to put 1, 16 right there, just above 15. Okay. So there's 1, 16. We also need to plot 2, 12. So let's plot 2, 12. Then 3, 15 is what we need to plot. So 3, 15. 4, 20. This can be our next one. So 4, there's 20. And then, so 20, remember, is just a little bit below 21. So there's 21, just below it would be 20, so I just kind of went over right there. That represents 20, that's fine. Now, we also have the coordinate point 5, 30. Let's go ahead and do 5, 30. 5, 30 is way up here. All right, so this data right here that we see, these coordinate points, this represents information. It represents the information of how many shoes were sold. So the coordinate point 5, 30 is telling us that after 5 months, 30 pairs of shoes were sold. This coordinate point right here tells us after 4 months, 20 pairs of shoes were sold. This coordinate point here tells us after 3 months, 15 pairs of shoes were sold. So coordinate points, in this case, just represents the relationship between how many months this place has been selling shoes and how many shoes they've sold. All right, so let's go ahead and look at our next example of how a coordinate plane can represent information. So it says, consider the pattern below built with cubes. Make a table and a graph on the coordinate plane to represent the relationship between the term in the pattern and the number of blocks in that term. So let's go ahead and look at the first one. In the first term, you see we have 1 block. In the second term, we have, let's see, this is 1, 2, 3, 4 blocks. So we have 4 blocks. Let me just put those numbers. It's actually good to write those in there. No harm in that. So 1 block, 4 blocks. This is 1, 2, 3, 4, 5, 6, 7 blocks. And then we're going to have to sketch term 4. So what we want to do is write a relationship, a table and a relationship describing what term we're on and what and then the number of cubes that we have. So term 1 has 1 cube. So that information right there is right here in the table. So as an ordered pair, we can think of this as one term, one cube. Now the second term has 4 cubes. So we're going to write this information in a table as the second term has 4 cubes. As an ordered pair, we have the second term has 4 cubes. Now the third term has 7 cubes. So the third term we're going to say has the number of cubes is 7. So that's 3 comma 7. Now we want for term 4, we want the number of cubes. Now we don't have term 4. We're going to sketch term 4. So there is definitely a pattern going on with these cubes. And if you notice, the pattern is that if you look at term number 2, for example, term number 2 had 3 on the bottom and 1 on the top. So we're just adding 1 on the left, 1 on top, and 1 on the right when we are drawing this pattern. Whoops, get that out of there. So that is our pattern. We need to add 1 more over here off to the side. We need to add 1 more over here, 1 more cube over here, and 1 more cube up here. So we're going to go ahead and draw that. So we need 1, 2, 3, 4, 5, 6, 7 cubes on the bottom. So there's 7 cubes on the bottom. 1, 2, 3, 4, 5, 6, 7. Oh, that's way too many. That's 8. There's 7 cubes. And then we need, the previous one had 2 cubes stacked up, so we need 1 more up here. Here's our third cube. So I'm going to draw just to give it a little bit of dimension. Okay, so we have some cubes here. All right, so there are cubes. Try to draw to give it a little dimension. Didn't work out too well. Maybe we'll stick with it. That's fine there. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cubes. So our fourth term had 10 cubes, so we're going to write the ordered pair 4, 10 on the coordinate plane. We haven't plotted anything yet, but we will in just a moment. Now, I could draw the fifth one, but hopefully we're noticing the pattern. And a big part of what we do in our unit linear modeling is understanding the pattern so we can make predictions about what's going to happen, so they don't have to keep continuing to draw out these things, and we'll just know based on the pattern. Well, if you look at the table, how much is it going up by every single time? Hopefully you can see we're increasing by 3 cubes every single time. So we don't have to draw the next one. If we just follow the pattern, we know the fifth term is going to have 13 cubes. So I'm going to write that as an ordered pair 5, 13, and we can graph all of those points. Now, there's we got our scales here. We have 1 through 5 for the x-axis, 1 through 10 for the y-axis, but the main problem is we have not labeled our graph yet. So if we go to our table, the term is going to be the x-axis, and the number of cubes is going to be the y-axis. Same over here. We have x term, and then y is the number of cubes. So over here, we're going to put, these are the terms. These are the number of cubes. All right, so our first term had 1 cube. So I'm going to plot the coordinate point 1, 1. So graph that one. Next, I'm going to do 2, 4. Put a 2, 4 there. And then 3, 7. And then 4, 10. And then 5, 13. Notice this one's off the graph. I have 5 and it goes all the way up to 10, but I'm going to need to get up to 13. That's no problem. We just extend that y-axis upward. If you need more, there's 11, 12, and 13. There is no harm in doing that. So I get all the way up there at 13. So we can see that pattern growing as the term grows. So there's a nice visual representation of how the number of cubes is growing. If you go ahead and flip it over to the back side, we're going to talk about the coordinate plane, but all 4 quadrants of the coordinate plane. We're essentially going to add the negative portion of each axis. So we talked about how the coordinate 0, 0, this is our origin. That coordinate point is called the origin. And we had this as the quadrant. We call this a first quadrant, or quadrant 1. But we also have other quadrants. The top left quadrant, this one's called quadrant 2. Remember, quad means 4, so we have 4 quadrants. Quadrant 3 is the bottom left one. We call that one quadrant 3, and this one is quadrant 4. So quadrant 1 is the top right one, and it goes counterclockwise. Counterclockwise meaning going this way. Numbered 1 through 4. So quadrant 1, 2, 3, and 4. So we have those 4 quadrants. We have the origin, and we have the x-axis. Let's go ahead and label that the x-axis, and this is the y-axis. So all of these things have names, and we just need to know the names so we can describe everything about the coordinate graph and what's inside each one of those quadrants. Now, if you notice, if you take any point inside quadrant 1, look at the x values. All of the x values in quadrant 1 are positive. Same thing with the y values. All the y values in quadrant 1 are positive. So anytime you have a coordinate point in quadrant 1, you're going to have a positive x value and a positive y value. That's not true for the other quadrants. For example, if you look at quadrant 2, look at the x values for quadrant 2. The x values for quadrant 2 are negative, while the y values for quadrant 2 are positive. So the x values are negative, the y values are positive. So let's go ahead and write that in quadrant 2, that any point you pick in that quadrant, x is negative, y is positive. Same thing with quadrant 3. It has its own unique set here of numbers. The x values are negative and the y values are negative in quadrant 3. So you'll have coordinate points that say negative, negative anytime you're in quadrant 3. For quadrant 4, we have positive x values. So that's positive x values. We also have negative y values for quadrant 4. So positive, negative is how you'll always have coordinate points in quadrant 4. And there's the complete coordinate plane with all the information that you need to know. You need to know the axes, the x-axis and the y-axis. So the x is the horizontal one, vertical is y. The 4 quadrants, and definitely the origin. We'll refer to the origin a lot as kind of like the starting place of the coordinate plane. And yeah, that's pretty much it. I had a class activity, a game that we're going to do together in class, but unfortunately I can't do it since I'm not there. So best of luck on your homework.